Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. So starting with the physiochemical properties, first you need to know what a solution is. So solution has two components. One is solute and other one is the solvent. The substance that is to be dissolved is the solute, and the medium which dissolves the substance is known as the solvent. For example, if you consider the example of water and salt in water, in that situation water is abundant in amount, so it will be the solvent, the medium which actually dissolves the substance, and the substance that is to be dissolved or the solute, that is salt. Then you need to know two terms. One is molarity, other is molality. Molarity, I used to remember it from this word larity and liter. So molarity is number of moles of solute per liter of the solution, whereas molality is number of moles of the solute per 1000 gram of the solvent. The main difference between the two is molarity, it is in liters, and molality, it is in kg. Also, molarity depends on the whole solution, whereas molality depends on the solvent. So we have this particular state which is known as the colloidal state, and colloidal state is further divided into two classes. One is crystalloids and another is colloids. So crystalloids are the substances which are crystalline in nature and they can freely pass the parchment membrane or semi-permeable membrane. These substances are sugar, urea, and sodium chloride. These are crystal in nature, like sugar is crystal, NaCl crystals are there. So these are crystalloids and they can easily pass the parchment paper, whereas colloids, these substance they cannot pass through the parchment membrane. Example, gum, gelatin, albumin. Albumin is a protein and it has a larger size and it cannot pass through the holes in the parchment paper. So that is why we divide the substances as crystalloids and colloids. Now we have colloidal state. What were colloids? Colloids were substances that could not pass through the parchment paper. So what will happen in there, that they will have a larger size. For example, the substances that are having size less than 1 nanometer, they can pass through the parchment paper, and these substances are characterized as crystalloids, whereas substances having length from the size from 1 to 100 nanometers and that have difficulty in passing the parchment paper, they are characterized as colloids, and they exist as visible precipitates. Like you see, when you are given certain antibiotics and they are white in color, and when you shake, you are advised to shake the solution of an antibiotic before taking it. It is because it is a colloidal solution and the particles, they need to be evenly dispersed throughout the medium. That is a real life example of colloid. Now we have phases of colloid. There are two phases. One is the dispersed phase and other is the dispersion medium. Like we did the solute and solvent thing, the same is here. Dispersed phase, which constitutes the colloidal particle, you can characterize it as the solute, whereas the dispersion medium or the external phase in which the dispersed phase is present, you can characterize it as a solvent or a medium in which the colloidal particles are suspended. So dispersion medium is the solvent, whereas dispersed phase is the solute. So classification of colloids. Colloids can be classified into lyophobic or lyophilic. There is dispersion medium and there is dispersed phase. If there is an interaction or there is some attraction between the dispersion medium and the dispersed phase, we are going to have lyophilic type of colloids. Whereas if they are not having any type of interaction or phobic, it means that it hates the solvent. So such substances do not have any attraction towards the dispersion medium, that is, there is no attraction between the solvent and the solute. And such substances, the lyophobic ones, are generally referred to as hydrophobic ones. Lyophilic, it means solvent loving. There's attraction or affinity between the dispersion medium, that is the solvent, and the solute, that is the dispersed phase. The term hydrophilic is used for the colloids when the dispersion medium is water. Hydro means water, philic means loving. So water loving substances, they are hydrophilic. And lyophilic, in most of the cases we have water as our dispersion medium, so we take hydrophilic as lyophilic. So we have two new terms. One is gel and other is sol. Gel is jelly like, whereas sol is solution like. So there are two types of colloids. One is jelly like colloid, other is solution like colloid. The jelly ones, they are very difficult to move. They have attraction between the layers, whereas the solution like, they do not have attraction between the layers, and that is why there is no hindrance, and they can easily flow and they can easily move. After that, we have emulsion. What is an emulsion? Emulsions are the colloids that are formed when two immiscible substances like oil and water. See, water is polar, whereas oil is non-polar. We follow the example of like dissolves like. So they both are not soluble in each other. That is why they are suspended with each other in the form of emulsions or in the form of colloidal solution. They can be stabilized by using substances known as emulsifiers. For example, there is a protein that is casein, which is present in the egg white, and it is an emulsifier for milk. Now we have micelles. For example, you have seen when you wash your hands and the water and soap, they do not mix with each other. Rather, they form colloidal solution, and that colloidal solution of water with soap is known as micelle. Now we move toward the properties of colloids. They have Brownian movement, that is haphazard motion. As you see, the motion of a butterfly, it is Brownian motion. Motion of particles that are diffusing, it is Brownian motion. So the motion of the particles in the colloidal solution is also Brownian or haphazard or random motion. Optical properties. When light is passed through the colloidal solution, it gets dispersed or scattered because certain particles they refract the light in certain direction, other particles diffract in other direction, as a result of which there is dispersion or scattering of light, and this dispersion is known as the Tyndall effect. In the electrical properties, the colloidal particles carry electrical charges. They can be either positive or they can be negative. The separation of charged colloid can be achieved by analytical technique or electrophoresis. There is a technique known as electrophoresis in which we can separate the positive and negative colloidal particles. So, what is osmotic pressure? Osmotic pressure is actually the pressure which stops the process of osmosis. So, particles which are smaller in size, they contribute a lot to the osmotic pressure, that is stopping the process of osmosis. But the colloidal particles, they are from 1 to 100 nanometers, and they are a bit large, so they do not relatively contribute to the osmotic pressure. So, they have non-dialyzable nature. What is meant by this? Actually, the colloid particles, as you know, since they have large size, they cannot pass through a membrane. That can be a cellophane or a parchment membrane. So this membrane allows smaller particles to pass through, whereas the larger particles, they are separated. So this process is known as dialysis, and colloid particles, since they are having a large size, they cannot pass through the parchment paper, they cannot be separated. So that is why they have non-dialysable nature. Also, we know the donor membrane equilibrium. So, what is this donor membrane equilibrium? It is actually an equilibrium between diffusible and non-diffusible ions or particles. Since colloid contains non-diffusible colloidal particles, so donor membrane equilibrium is very hard to achieve in colloids because they lack a large amount of diffusible ions across the membrane. Hence, donor membrane equilibrium is hard to achieve in colloids. Now we will study certain examples of the colloids in our daily life. One is biological fluids as colloids. You know, the milk, the blood, and the cerebrospinal fluid that is in the central nervous system, the brain, and the spinal cord, they are colloids. They contain non-dissolvable ions. Biological compounds as colloidal particles. There is another example. The complex molecule of life, that are protein, there are lipids, there are polysaccharides. These substances, they are not soluble in our blood, in our other fluids of the body. Hence, these substances make colloidal solution with our main solvents. Blood coagulation. When blood clotting occurs, the soul, that is the liquid portion of the blood, is converted into gel, that is coagulated form of the blood. This is what happens in blood coagulation. Or you can say water. You can say blood loses its liquidity and becomes solid or jelly-like substance. So it becomes from a solution state to a gel-like state. Fat addition absorption. As we know that fats are absorbed in the form of emulsion, and this allows the fat absorption to take place very easily. in the intestinal tract or in the lacteals of the small intestine villi. So, fat digestion and absorption depends on the formation of the colloids in our intestinal villi. And formation of urine, as you know, urine is based on the principle of dialysis, and we know that colloidal particles are non-dialyzable nature, so it helps in separating larger particles and smaller particles, and helps in the reabsorption and the tubular secretion process of kidneys, etc. Coming to our first property, the physiochemical property, which is diffusion. Diffusion is the movement of molecules or solute molecules from an area of higher concentration to an area of lower concentration. For example, you have this type of membrane and a large number of particles are present over here. So what would happen, that according to the normal process of diffusion, they will move from an area of higher concentration to an area of lower concentration. Diffusion is more rapid in substances which are having less number of interaction between them. That is, diffusion is more rapid in liquids, in gases than in liquids, because gases have least interactions than liquids and then solids. Diffusion is very slow, very slow in the solids. And diffusion occurs in true solution, but it is very much difficult in gel solutions, etc. Now, examples of diffusion being carried out in our body are exchange of oxygen and carbon dioxide. They occur in lungs. Then nutrients, they are absorbed by the process of diffusion. These nutrients are pentoses, water soluble vitamins, and diffusion process is also occurring in our certain kidneys, etc. Passage of the waste products, namely ammonia in the renal tubules, occurs by diffusion. So both these example, one is nutrient absorption, other is some ammonia or ion absorption. These occur in kidney tubules, and exchange of oxygen and carbon dioxide, it occurs in the lungs by the process of diffusion. The word osmosis, it comes from the Greek word which means push. So what is osmosis? It is the movement of the water through a semi-permeable membrane from an area of lesser solute concentration to an area of higher solute concentration. Now here we refer to as solute. So it moves from less area, so there's a semi-permeable membrane, it moves from less solute concentration to a heavy solute concentration area, and this process is known as osmosis. Very much important point over here is that the semi-permeable membrane in osmosis must be permeable to the solvent and not to the solute particles. Now, osmotic pressure, the pressure that must be applied in a solution to stop the process of osmosis, is known as the osmotic pressure. And osmotic pressure is a colligative property. It depends on the number of the solute particles and not on the nature of the solute particles, not depend upon their size or their mass. It only depends upon the number of the particles, whatever their size or shape or weight might be. Now, another two words that you need to do and that you need to know are isoosmotic and isotonic. Molecules or solutions having the same osmotic pressure, they are known as isoosmotic. Iso means same, osmotic pressure. So same osmotic pressure by different solution, they are said to be isoosmotic. And isotonic is said to be a state. So iso means same and tonic means tonicity. So what happens if you place red blood cells in a solution of 0.9% NaCl? So they will have same tonicity and no water will move into or out of the cell. So net pressure will be net movement of the water into and out of the cell will be zero. So such solutions are known as isotonic solutions. But when the amount of the NaCl in the solution is increased, for example, it is increased from 0.9 to 1.1 or something greater than that, what will happen? The water will start to move out from the cell into this area, from an area of lesser solute concentration to an area of higher solute concentration. So in such a situation, the solution will be hypertonic and water will move from the cell into the solution. Now what happens in if we decrease the NaCl in the water? What will happen if we take it to 0.6 or 0.5? So the the cell will have more solute as compared to the exterior. Such a solution will be hypotonic. Hypo means less. So it is known as a hypotonic solution, and water will tend to move inside the cell and the cell might swell or burst. And when we refer to the osmotic pressure of the colloidal substances like albumin or globulin, these substances, which are colloidal in nature, they exert oncotic pressure. Their osmotic pressure has a special name, that is oncotic pressure. And unit of osmotic pressure, they are milliosmoles. So, fluid balance, application of osmosis. So, fluid balance and blood volume, the maintenance of the fluid balance in our body, like the fluid balance in blood, cerebrospinal fluid, different compartments of the body, regulation of the blood volume, and urine excretion, it depends upon this method of osmosis. Red blood cells and fragility, I explained all of this topic lately. The 0.9% was isotonic, no movement into or out of the cell. 1.5% becomes hypertonic, water flows out of the red blood cells, whereas and the cytoplasm shrinks and there's crenation. Whereas in zero point 0.4, that is less than this one, so water will tend to move inside the cell and the cell will rupture and there will be hemolysis of the cells. And this is done to check the osmotic fragility of the red blood cells. Increased fragility, that is seen in hemolytic jaundice. Hemolytic means destruction of red blood cells, and jaundice is a disease in which there is yellowing of your skin color and there is bilirubin accumulation. Now we have transfusion. So we did fluid balance. After that, we had fragility. After that, we have transfusion. So isotonic solutions of NaCl, that is 0.9% glucose or sucrose, 0.9% NaCl or 5% glucose. Their suitable combination is given to treat dehydration. As you know, osmosis is required to maintain blood volume or level of the body fluids. So in transfusion, such isotonic solutions are very much important to maintain the blood volume or water balance in our body, and they are given for the treatment of dehydration. Now we have purgatives. So these purgatives are given, and what happens now? As you know, these are solutes. So water tends to move in osmosis, water tends to move from area of lesser solute concentration to higher solute concentration. When we have these solutes circulating in our blood, so water will not go out of your body, rather it will stay in the body, and intestinal water absorption and water will try to move into your blood. So what will happen, that the absorption of water in the intestine will also be prevented. This is the action of purgatives. So what happens in high blood glucose concentration? Osmotic diuresis is seen, in which there is loss of water, electrolytes, glucose in the urine. And when there is glucose in the urine, it produces polyuria, which is observed in the disease of diabetes mellitus, or we can say that they have sweet urine. That is a very bad state. Diuresis, that is to increase the urine production, that is given by, or that is contributed by compounds like mannitol. We know the process of diuresis is prevented by the hormone ADH, or antidiuretic hormone, and it is promoted, the process of diuretic is promoted by the mannitol, which causes increased production of urine in the body. Now we have a state of hypoalbuminemia. Hypo means less and albumin are certain proteins. As you know, the osmotic pressure that is exerted by proteins is known as oncotic pressure. So when there will be less oncotic pressure, so water will not move into the cells, rather it will stay accumulated in the tissues. In such a situation, accumulation of water in the tissues will produce edema or swelling of different body parts. Using the same concept that we studied in the red blood cell fragility thing, that was whenever there is high concentration of the salts, the cells will become flaccid and water will tend to move out of the cell. So what will happen in cerebral edema, that is, there is accumulation of water in the brain cells. So what will happen, what will we do, that we will give high salt content, that is, we will give high values of NaCl or magnesium sulfate. As a result, the water may move out of the brain cells into the blood circulation, and it will reduce the intracranial pressure exerted by the cerebrospinal fluid. Now, irrigation of the wound. isotonic solution, that is 0.9% NaCl or 5% glucose. Mainly 0.9% NaCl is used for the washing of the wounds. The pain experienced by the direct addition of salt or sugar to wounds is due to osmotic removal of water. So we do not put um, salt or sugar, rather we use a isotonic solution, so there is no net movement of water into or out of the cell, and it does not produce any irritation to the patient. So we have the donor membrane equilibrium. That is a very difficult concept for some students, but I will explain it to you very easily. Let us move to it. So presence of a non-diffusible ion, a ion which cannot pass the semi-permeable membrane, it alters the diffusion of the diffusible ions. Let us see what happens over here. So we have sodium, which is a diffusible ion. We have chloride, which is a diffusible ion. But we have this proteinate, which is a non-diffusible ion. So what happens? Sodium can pass through, chloride can pass through, but proteinate will stay over there. So, what will happen in the equilibrium state is that the area where proteinate is present, it will attract more of the solute particles towards it. There will be net movement from an area of lesser solute concentration to an area of higher solute concentration. That is the main phenomena of osmosis. And this proteinate ion, it cannot move across the membrane, so it will cause higher osmotic chemotaxis, or higher attraction towards it. As a result of it, the ions will be attracted towards this side, and the osmotic pressure over this side will be greater as compared to the side 2. This is the Donan membrane equilibrium. So in this equilibrium, there will be higher concentration of ions on side 1, and there will be lower concentration of ions on the side 2, but the net movement will then come to an end because of an unstable equilibrium that is now maintained. Now, this Donan membrane equilibrium is very much important. As you know, the lymph and the interstitial fluid, they have lower concentration of these sodium and potassium ions and higher concentration of the chloride ions. This is because there is a high proteinate content in plasma. When there's high proteinate content, what will happen? The ions will be attracted towards this side, and the concentration of the solute will be higher in the plasma. Then membrane hydrolysis. The relative strength of H positive and hydroxyl ion, that is the acidic or alkaline nature, is influenced by the presence of non-diffusible ion. Since our gastric juice contains a large amount of the non-diffusible ions, so what will happen? H positive ions will be attracted towards the gastric juice side. So this Donan equilibrium is very much important in that process of gastric juice hydrogen ion concentration. So now what happens in RBCs? Consider this in RBC, and this is the plasma. So plasma has a pH concentration of 7.4, that is a little bit higher, whereas the red blood cells, they have of 7.25. Why is that so? It is because the red blood cells contain non-diffusible ions. These ions attract the hydrogen positive ion to the interior. When these H positive ions come to the interior, they reduce the pH, so it decreases from 7.4 over here to 7.25 in the interior of the red blood cells. Because in our different body parts, we have different presence of the non-diffusible ion. These non-diffusible ion actually have a concentration of different osmotic pressures in different compartments of the body. Like in plasma, there's high osmotic pressure, whereas in other parts of the body, there's low osmotic pressure. And this osmotic pressure is maintained by the Donan membrane equilibrium concept, and it helps to maintain or to provide the amount of water or the amount of the substances that are needed by different cells. Like liver has different requirements, kidney has different requirements, and that requirement are filled by the Donan membrane equilibrium method. As we know, we have the dialysis method. So what happens in the dialysis method, that we actually clear your normal blood from extra ions, and this is also maintained by the presence or by the method of tone and membrane equilibrium by using the concept of non diffusible ions.